All right, everybody, welcome to Geology. Let's talk structure. And again, using this as a way to do some review from segment 2 of the course, tectonics, just like yesterday's video or the last video you watched, whenever that was. This little thing is stolen right from those notes back then. And we did a fairly detailed diagram here, which I'm going to only steal certain parts of. So I do recommend, as part of prep for both this week and the final, going back and checking out some of this from segment 2. Because what a lot of this that we're about to talk about has to do with is the difference between the layer on top and the layer on bottom, being the lithosphere and the asthenosphere. Now, again, when we did this at the beginning of the term, we also threw in the crust and the mantle here, and we talked about all those separate little layers in the moho and where that is. You'll want that. I'm not saying it's not important because I'm not writing it. I'm just simplifying for today to say that what's the difference between what goes on in the lithosphere and the asthenosphere with stress and strain, and then within strain, brittle and ductile deformation. Sound like a plan? Sound exciting? So stress versus strain. First off, let's do that. This little section of the book right here, 13.1, does a fantastic job. So check that out. That stress is really the word that goes with the force, and strain is the word that goes with the change in shape. So if you hear somebody say that they're under a lot of strain at work, if you're being literal with language, that would mean that like their head is being misshapen by their workload, physically misshapen. That's like the technical definition of what strain is. It's misused in like common everyday language, which is fine, right? But if we want to talk about it here accurately, stress is the force, strain is the change in shape that results. And these were in the last video you watched, talking about the types of stress. And then the strain would be, how does the rock change shape in response to that? Elastic, and I didn't put this on the note sheet, but it's important to note, and if you remember elastic rebound theory from back in earthquakes, that's the idea that like a rubber band, if you pull on it and then let go, it will rebound back to its original shape. But there gets to be a point where if you pull on it too much, then you've gotten past that threshold where it will indeed break. That is the kind of idea that works along faults, where if a rock can have some sort of differential pressure on it and it wants to go, if that tension were magic, or the shear force were magic wanded away, the rock could return to its original shape. But once it slides, that's what releases the energy waves for the earthquake. So note that there. I'm not going to write the notes for you. You can jump in and do it if you'd like. But keep that in mind from section 13.1. Again, that can be right here. Okay. So now the types of strain that we might talk about, and the reason why I throw lithosphere and asthenosphere here is because that pretty much determines where these things are going to happen. The lithosphere, Earth's crunchy outer layer, tends to be where brittle deformation happens. Your book uses this diagram where this is a test cylinder of rock. I actually used to, it looks like some sort of fine granite. I used to test commercial concrete, where we would make, when they were pouring concrete for commercial sites, we would make little test cylinders, I think 6 inches by 12 inches probably. And then in the lab, there was a machine that would compress them until they failed, until this happened, and bits of concrete went flying all over the room. Then the little needle would measure the PSI, and we'd note how strong that concrete ended up being that was poured. Now that is the example of brittle deformation, that cracking, right? And that is what we would experience in the lithosphere in general. That crunchy outer layer, when it fails, will crack. Versus when you get warm enough down here, not a liquid yet, but when you get warm enough in this Play-Doh-like, thicker than that, but Play-Doh-like, where it can flow, asthenosphere, that's where you can get ductile deformation. Now your book shows this as an example. This actually has both. Can you see how once it was put under that compression, that it got kind of blown out on the sides here. It got a little rounder. So that's the ductile deformation. And the book does say this. It deformed ductily before deforming brittly there. So that did a bit of both, right? Which is reasonable to picture happening within the Earth. And that's where these little graphs right here are kind of interesting, because it shows us at what temperature and at what pressure do you have to be on either side of that line. And look how dramatically different it is when rock is under tension versus when rock is under compression, because of the nature of those pressures and what that does. It's kind of interesting. All right. So yeah, boot ends. Have you ever heard of the like Cajun sausage? This is another example of when you can get a bit of both. This is an indication of some ductile deformation happening. So this is like, okay, now we're looking actually at the rocks and incorporating all of this, right? We get some of the ductile deformation happening, and you can see these like the lines where it looks like it's flowing, and some of the stronger rock underwent that brittle deformation. That'd be the hard, the more resistant stuff, the harder stuff that cracks rather than flows. And it's, you know, where life gets complicated. If it were as simple as a concrete cylinder and a cylinder, this is not wax, but let's say it's wax, where you can picture a candle like mushing, right? That's very discrete, very simple, very easy to spot. But get into like real life geology, where we've got layer upon layer of different rock, different pressure from different directions, it gets much more complicated. So what does it look like near that transition zone? It's going to be areas where you get a bit of both. And that's where those sausage formations might take place. Where's my notes? All right. And that's there. So really, I'm going to cut this one off and be short on this. What we'll get into then for the last video is the types of things that can happen, which really then, getting close to the end here, solves all of the puzzles of geology by saying that here's how everything has formed based on all the rules that we know, like what types of rocks are these, what did they look like originally, what did they come from, and what has happened to them since. Fracturing, where you got actual cracks in the rocks, and we'll talk about two different types there, joints and faults. Tilting, if you've driven around and seen road cuts, there's no way you haven't seen that. And that will also be part of like folding, where this could be a big picture. This is a big going up one side and down the other. We'll talk about anticlines and synclines with that. Stretching, and I mentioned this in the last video. I said the book is a cool photo where when it's under tension, the rock takes up more space. So you can see that like this layer that might have been intact has now been spread out because that rock has been elongated out. And the types of faults, which really are we'll mention that with both of these, I suppose. All right. Any last minute things I want to see in the book? I think we're good. We're going to do that in the next video. And yeah, it will be good. All right. Thanks, everybody. Almost there. Good work. Keep it up.